So last class we had a discussion on CMCGT. It means contribution of tail towards quotient of pitching moment about center of gravity. It is about the tail alone. That is minus eta VH CLT. So what is VH? VH is horizontal tail volume ratio. So what is horizontal tail volume ratio? It LT ST by S into C. This is the location of the tail from the center of gravity in the downstream direction. This is the planeform area of the tail, and this is wing planeform area. C is the chord of the wing. This is how we characterized. Now we will try to understand it further details and open up into further details. So from the diagram, we'll try to rewrite this into a different format. Rewrite into different format. That is, look at the diagram alpha t, just write all of you. Angle of attack of the tail is equal to, I will tell you some connection, alpha WB minus IT. Just check all of you. And because you need to involve all the angles of attack, tail setting angle, downwards also into the picture, into this equation. This is simply a CLT, but other further details are not included in the actual equation. So we will try to elaborate this in terms of various other what are the other parameters which are not coming into picture now. If you confirm this as the CMCGT, look at the diagram. In the diagram we have many other parameters. I said the tail setting angle, okay, and we said downwash angle, and we said alpha WB. All of them should also be incorporated into the equation, right? So let us try to incorporate those parameters and write an elaborate equation. Then we'll argue with further details. Okay. So this, is it right? Please look at the diagram. Is it okay? Alpha t is equal to alpha WB minus IT minus. Just check once. You check once from the diagram, diagrammatically. Then we'll try to process this. CLT can be written, CLT can be written general sense from the alpha t versus CLT. How else we can write this CLT from the lift curve? Just imagine. We are trying to write in different formats. What is the slope of the lift curve of the tail? I can write it to be DCL T by D alpha T is equal to, how do you write this? Between 2 points? CLT minus, let's say, alpha t 0, CLT 0. How do you write the slope equation between this point and this point? CLT minus 0 minus alpha t minus 0. So slope of the lift curve, write down, slope of the lift curve of the tail can be written as like this. Then CLT can be written as conventionally AT alpha t. Is it right? So we know the slope, we know the angle of attack of the tail. So all of them can be written as CLT only. Coefficient of lift can also be written like this from this. This we have been writing in the same format. Is it okay? Look at the previous expressions also. We wrote this in the wing alone combination. Please check once. There we introduce alpha W in terms of slope and angle of attack. If you only refer it continuously, you will get the simplest possible format. Wing alone combination also we had this particular discussion. Check once. Is it available? So this is one incorporation I would like to do. So CLT. What is CLT? Coefficient of lift of tail at one particular angle of attack is written. So what is alpha t? Look at what and all we are trying to do. AT into alpha t contains these many things. Alpha WB minus IT minus epsilon. So CLT is elaborated. Okay. Coefficient of lift of tail is elaborated. Okay. There is some empirical way of, though it is not very significant, due to the wind tunnel experimentation, they formulated one particular expression involving downwash. Please write down. Downwash angle. Downwash angle. Write down. Downwash angle is empirically noted, but uh, we need to consider by the experimentation. Epsilon naught plus dou epsilon by dou alpha. Keep this format. Dou alpha into, take it as it is. Due to the experimentation, how do you measure the downwash angle? Downwash angle, by doing the experimentation of the wind tunnel, it is identified. This is following this relation. Okay, dou epsilon by dou alpha. Epsilon naught is at angle of attack 0. What is the downwash angle? This is the slope of downwash angle to at various angles of attack. This is the slope of the angle of attack, and this is at a given angle of attack of the wing. This is the empirical formula. Just keep it as it is. Let us try to incorporate into this in the form of CLT. I will tell you an elaborate formula that is going to give us the picture about original uh, contribution of tail towards pitching moment, acting about center of gravity, tail alone. Then we will add the contribution of the wing and we will make all the arguments finally. Because we made wing contribution alone, tail contribution we made almost. We'll tell you few more things. Now combinedly, how to design the aircraft in the perspective of longitudinal serviceability, contribution of wing and tail together we have to talk. That is the actual one. So when I write, now complete this. How do you write CLT? Basing on this expression is equal to, write down. This is one additional thing which I ask you to take up as basically an empirical proposal with regard to downwash angle. CLT should be written as AT, segregate the terms AT alpha WB, AT alpha WB, I will tell you and then we'll write. Write down. AT alpha WB into 1 minus dou epsilon by dou alpha. Is it right? AT alpha WB 1 minus dou epsilon by dou alpha. This is a small term, don't worry. When I write the complete thing, you will get it. This may be troubling, that's all. This is the only aspect that is troubling. Other things are straightforward. What next? Minus of AT Minus of AT, IT, minus or plus. Please check once this whole format. Substituting this into this, what is CLT? Now write CMCGT. CMCGT is equal to, please write CMCGT. All of you please involve and write. Minus epsilon VH AT alpha WB 1 minus dou epsilon by dou alpha is one term, plus or minus, plus, plus eta VH eta VH AT into IT. Please confirm this step. That's all. There is no more simplification. This is the elaborate format of contribution of tail towards longitudinal static stability, or this is the amount of pitching moment that a tail can create or develop about center of gravity by taking the aerodynamic effects of the wing, because wing portion is not involved. It is not the complete a total pitching moment. It is only pitching moment contribution by the tail alone about center of gravity. But what we have taken, epsilon came into picture because V prime and V infinity difference. So effects, aerodynamic effect of wing are taken to take the upstream characteristics of tail. Okay. Now looking at this, we can make some argument. Previously, what was the discussion we made? CMCGT is equal to minus epsilon VH CLT. What is the purpose of tail now? Longitudinal static stability criteria, please look at now. Dou CMCGT by dou alpha T should be dou CMCGT. What is the criteria? Find out. Is equal to negative or positive? Dou CMCG by dou alpha of the tail. Criteria. Negative or positive? Negative. Talk loud. Negative. CM naught should be positive. Please find out whether the contribution is stabilizing contribution or destabilizing contribution by attaching the wing, by attaching the tail, by attaching the tail. Dou CM CG by dou alpha tail components. Differentiate this with respect to alpha T. What do you get? The tail. Differentiate with respect to alpha, only one alpha is there, so you can take up alpha WB, no problem. Dou CMCG by dou alpha of the tail. T means, doesn't mean it is alpha T. What is available here? Alpha WB. With respect to everything is alpha means gross alpha. Okay. Differentiate with respect to alpha, what remains? This whole thing is a constant, right? Slope is a constant. If the tail is chosen, this is a constant. This is like a small constant. Tail setting angle, because all are constants. So what is the differentiation? When you differentiate with respect to alpha, minus eta VH AT 1 minus dou epsilon by dou alpha. It should be negative, but it is appearing to be negative. Whether it is really negative, we will see. Because format was negative. So it deceives sometimes. And MCG, not MCG, CM not contribution by the tail, CM not contribution of the tail. So substitute alpha 0, alpha 0. What do you get? Eta, VH, AT, IT plus. See, every component should contribute to satisfy the criteria. Together, we have to see to that how to make the criteria rule should be satisfied. First of all, what is happening when you attach the tail to the aircraft with regard to longitude, stability, and with regard to criteria? Is it a stabilizing contribution by this? Minus is there. Look at now whether this value is positive or negative. This value eta, ratio of dynamic pressures, is always positive. This is the geometry property. Horizontal tail volume ratio, is it positive or negative? Positive. Slope of the lift curve of the tail is always positive. This whole thing is positive, let's say. So this whole thing is positive, so no problem. Minus is not becoming plus. So it is dou CM CG by dou alpha by attaching the tail is negative. So contribution is stabilizing contribution. It creates a restoring pitching moment to the aircraft. The disturbing pitching moment is opposite to this. Okay. CM naught should be positive. Whether really positive, looking at the parameters. This is positive. VH is positive. Slope is positive. Difference should be IT plus epsilon naught. Is positive or negative? So CM naught is positive. I will make one particular point. You just look at carefully. Write two statements now below this. The wing contribution to because it's a balancing parameter. Wing contribution to CM naught W is CM naught W by the wing alone configuration. Tell me, it was negative or positive? CM wing contribution. I am talking about wing. Contribution of the wing is equal to CM AC. CM not equal to CM AC. CM AC by the property of cambered aerofoil is negative. So CM naught is negative. Negative. So the balancing takes place at the negative angle of attack. Equilibrium angle of attack would be negative. So that is not preferable. We need to always bring the balancing angle of attack or equilibrium angle of attack should be positive. Otherwise, aircraft should always find a positive angle of attack as equilibrium angle. That is a desirable condition. Here, it is finally for the whole aircraft, fuselage, wing and tail, CM naught should be positive. So contribution of the wing is negative. Look at the tail contribution to CM naught. Like how to make how to balance the aircraft at positive angle of attack. So by attaching the wing, is it happening? CM naught T is equal to is positive. It is positive only when tail setting angle is horizontal tail. Look at the diagram. Horizontal tail is fixed below the fuselage reference line. Then only it will be satisfying CM naught positive by the tail contribution. If the opposite is set, suppose tail is set above the fuselage reference line, then this will become negative. But by the diagram, IT is positive. Downward setting angle of the tail is considered as positive in our derivation. So IT is positive according to us. So CM naught is positive. Suppose if you set the tail opposite or above the fuselage reference line, what will happen to CM naught? CM naught becomes negative. Contribution of wing itself is negative. Tail contribution also will become negative if the tail is set above the fuselage. So this is the reason. So we need to set the tail below the fuselage reference line by an angle IT. Then only the negative value contributed by the wing and positive value, how much amount of positive value you need, all of the parameters will dictate. If there is a trimming required or adjustment required in the design itself, tail setting angle, if you just take a suitable or convenient value, then you can achieve the balancing of equilibrium angle of attack of aircraft as the positive angle of attack. So all the parameters should be looked into. Now look at here. So these two things, please write down. The tail contribution Cm naught T. Next point. The tail contribution Cm naught T can be used to ensure Cm naught for the complete aeroplane is positive. Wing is contributing negative, tail is contributing positive. The sum should become positive. That much value you have to generate. Suppose the value is small, contribution by the tail, then it is of no use. Minus plus a value should become positive, such that you have to fix the parameters. Your horizontal tail volume ratio, lift curve, slope of the lift curve of the tail setting angle, this is a small value. All of them put together should make negative plus positive value should become positive. Positive, then only aircraft will be balanced at positive angle of attack. That is an important point. Write down. Can use to ensure the Cm naught for the complete aeroplane positive. This can be accomplished by adjusting the, tell me, tail setting angle below FRL, fuselage reference line. Please go through the content once. Okay. Look at now. Contribution of the wing alone combination dou SCMC by dou alpha. Because of a case where how dou CMC by dou alpha by the wing can be made negative only by the choice of selecting center of gravity ahead of, that is not possible. Ahead of center is very close to the nose. So to overcome that, if the tail is attached, these many parameters together should handle the value. So you have to properly select the VH and AT. So finally, the selection of aerofoil of the tail it places a dominant role in dictating the magnitude of dou CMC by dou alpha, and prime most thing is horizontal tail volume ratio parameters you have to adjust such that that value is such it is able to make the summation of the dou CMC by dou alpha of the W wing body plus dou CMC dou alpha tail should become together it should become look at now, dou CMC by dou alpha is a positive by the wing plus contribution of tail is negative. The summation should become positive or negative. Negative. That larger value you have to get. You didn't get the point. Dou Cm Cg by dou alpha of the complete aeroplane is dou Cm Cg by dou alpha of the wing and body plus dou Cm Cg by dou alpha of the tail. So this whole thing should be negative. Then only it satisfies the longitudinal static stability criteria. Slope is negative. But by the contribution of the wing, what is this value? Positive. Positive value. By the contribution of this value, negative. This value, which value should be larger to make the summation negative? This value, this value should be a larger value. Like that, you have to, that is the design process to make the aeroplane to possess longitudinal static stability. That is the contribution of the tail. So, tail design is essential to make aircraft longitudinally stable. So, look at this is the idea of aircraft design. Did you get the point? So, what are all the choices you have? The choices are only selection of aerofoil and its slope of the lift curve and horizontal tail volume ratio. So that's all. Horizontal tail volume ratio means location of the tail is also one parameter and plane form area of the tail is also another parameter in the numerator. In the denominator, wing parameters are there. So that ratio should be the crucial parameter. So look at once now. Just look at once. Did you get the point? So we want this to be more negative value, right? Dou CMC by dou alpha should become more negative. Now tell me, it should to become it to more negative, VH value should be higher. VH value should be will be higher if the tail is positioned possibly far away from the location of the away from the center of gravity, and possibly you select the plane form area of the tail. These two values should be at a higher side, and slope of the lift curve of the tail should also be a larger value. Then only your required value of the dou CMC dou alpha magnitude can be attained. Negative, more negative value. Okay. More importantly, write down dou CMC by dou alpha t will become more negative, will become more negative by increasing the tail momentum LT. The name of LT is tail momentum, location of the tail with respect to the center of gravity. LT is what? Is a momentum, or the location of the tail with respect to center of gravity in the downstream direction, and or tail surface area, or by increasing slope of the lift curve of the tail AT. Anything you have to increase depending on the requirement. So when you go into the real design only, you will see what is to be increased, whether can be increased, whether can be increased. So the designer can adjust any of these parameters. Right on. The designer can adjust any of these parameters to achieve the desired dou CMCZ by dou alpha t. Write the statement. The designer can adjust any one of these parameters to achieve the desired dou CMCG by dou alpha t. So the conclusion is, please write this is the conclusion. The whole discussion, this statement is the conclusion. The conclusion is a tail surface located, a tail surface located aft of the wing, aft of the wing can ensure that the aeroplane has can ensure the aeroplane has positive Cm naught and negative dou CMCG by dou alpha for the whole aeroplane. Don't write suffix t. For whole aeroplane, Cm naught can be positive whole aeroplanes dou c into dou alpha negative by keeping the a tail surface aft of wing. Is it understood now? Design essence. If one component is contributing negatively, adding another component suitably, summation should become the required sign. Right, tell me. Positive cambered aerofoil, CM naught is no, CMAC is negative. Moment about aerodynamic center is by the property negative. Since CM naught is equal to CMAC, CM naught is negative. So for the wing, not positive cambered, wing alone combination, if the positive cambered aerofoil is used, the CM naught is finally negative. Negative. What is the problem if CM naught is negative? What is the problem if CM naught is negative? I will clarify now. Is it the one? So I'll talk about CM naught actually doesn't directly convey anything related to stability. It conveys something related to. No, let's look at now. I will pose certain questions now. You please answer. So tell me what is the look at the criteria of longitudinal static stability. What is the criteria? It is the CMCG versus alpha of the whole aeroplane. Okay. So we had a discussions. We had discussions. This is how the aircraft. See, these are all the restoring pitching moments if aircraft is disturbed from its alpha trim or equilibrium angle of attack. If aircraft gets into increased equilibrium angle of attack due to disturbance, aircraft should try to return towards equilibrium angle of attack. How that is possible? Only by creating this type of restoring moment. So, what is the type of restoring moment aircraft has to generate if it is disturbed from equilibrium angle of attack is the criteria. That's not that, it's the behavior of aircraft during disturbance. That is the behavior of aircraft we want when it is disturbed to travel towards equilibrium condition. That is the criteria. People have the misconception on this. Okay. Now, what is that we identified? So, what kind of aircraft it is? If this is the behavior, if you find. If you find this behavior, what is stable aeroplane? What is unstable aeroplane? This is unstable. Why? This is stable. Longitudinally stable or longitudinally unstable. Is it understood now? We are going to represent the whole discussion in terms of mathematical format. So, to have the longitudinal static stability, we can say dou CMCG by dou alpha should be negative. This one. That's what you understand. Dou CMC dou alpha should be negative means contribution to the wing and tail should become this equation negative. Now look at now dou CMC dou alpha we had in the previous discussion. We didn't understand what is how to find out dou CMC dou alpha. CMCGW plus CMCGT, there will be an equation. Differentiate with respect to alpha of the aircraft, then that value should become negative. If it is becoming positive, how much value you need? Choose the parameters accordingly. Finally, the whole dou CM will become negative depending on the parameter selection, distances, plane form area, tail setting angle, selection of aerofoil. All of them should together make this negative. Wing anyway is contributing in a destabilizing manner because of inability to position the center of gravity ahead of aerodynamic center. That is why the purpose of tail came into picture. So CM naught, I will talk about this. Now, in the same vein, when alpha equal to 0, this value is called CM naught. So CM naught is positive. CM naught is positive. So these two things we laid under longitudinal static stability criteria. But truly CM naught positive, does it represent stability criteria? That's that's the discussion I make. Supposing, look at this. I make another diagram. So stability criteria, same graph. Suppose, is it stable or not? If aircraft behaves like this, we said because this should be negative. This is negative. This is also negative. Slope. Two things we take up. Is it not a stable aeroplane? Which is stable aeroplane? This is a positive slope should be unstable. Positive, if the slope is positive, then only it is unstable. But if I make the diagram like this, what is the difference between these two? Slope is negative, stable. But only thing is Cm naught. Here it is positive. Here Cm naught is negative. That's all. Cm naught negative means what? No, 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 no. Cm naught negative, but slope is negative. Slope is negative. Cm naught negative here. Still slope is negative. Stable or unstable? In this case, aeroplane is balanced at what angle of attack? Balancing angle of attack. Equilibrium angle of attack is alpha trim. Hmm. Alpha trim is, here alpha trim is positive. Here alpha trim is negative. Stable only. Aircraft will always look for a balancing angle of attack as negative angle of attack. Still stable. It doesn't question anything about stability. It questions about equilibrium angle of attack. Suppose if aircraft is disturbed, this aeroplane always looks for what type of equilibrium angle of attack? Once it is disturbed from equilibrium, it's equilibrium. What is equilibrium angle of attack here? This is alpha trim. What is alpha trim for this graph? Negative. Look at the way. Look at what is Cm naught. Hmm. This is equilibrium angle of attack for this particular airplane. This is equilibrium angle of attack of this aeroplane. What is the difference between these two? Please note down this and have a discussion. Aeroplane can be still stable if Cm naught becomes negative, then hmm, equilibrium angle of attack or trim angle of attack, it is negative. Negative is not desirable. That's okay. Negative is not desirable. Positive is desirable. Negative Y is not desirable. How the aeroplane always try, it always tries to point towards this way. If the positive Cm naught is positive, stable aeroplane, Cm naught positive, if any disturbance created other than equilibrium angle of attack, aeroplane will always try to look for equilibrium angle of attack as positive, so that aeroplane will fly high. It will fly low. So it is not a desirable Cm naught, write down. Cm naught is positive, desirable. This is undesirable. Both the aeroplanes are stable. Both the aeroplanes are stable. Did you get this point? Now look at this aeroplane. Supposing unstable, if you look at it, can we make any discussion? Let's see. Hmm. Both are unstable because this curve can be made, positive slope can be made in any manner. If this is what we know it. Stable or unstable? Unstable. Cm naught is negative. unstable. Cm naught is positive. It is unstable. Cm naught is positive or negative. How does it matter? Only thing is stability. So this particular aeroplane will always try to look for equilibrium angle of attack as positive, but it is primarily not a stable aeroplane. So Cm naught positive, what type of criteria it is? Cm naught positive is a balanced criteria. Whether aeroplane is balanced at positive angle of attack, that will be decided only by the Cm naught as negative or positive? Positive. So can someone consolidate this? These two. This is an important discussion. Though we keep under longitudinal static stability, this particular Cm naught positive, it is desirable condition for alpha trim positive. The balancing will take place positive angle. That is a desired condition. So that is why it is also kept under the criteria. Follow that rule also. Otherwise, strictly speaking, stability criteria is dou CMC by dou alpha should be negative. Cm naught positive is not the primary criteria. What is that criteria? That is a desirable criteria. Essential and desirable. What is essential? Dou CMC by dou alpha should be negative is essential. What is desirable? Cm naught should be positive is desirable. It is not essential. Aeroplane can still be stable if Cm naught is negative. Right on. Dou CMC by dou alpha is equal to negative is an essential criteria for longitudinal static stability. Cm naught is positive is desirable condition. So that is the extent of understanding. If you follow it, no problem. Otherwise, don't worry. Okay. Any further discussions? Yeah, look at once. I will